So how do we go about proving a statement of the form h1 and h2 and h3 up to hn logically implies C? Let P be the proposition that says h1 and h2 and h3 up to hn. In this case, the following questions are equivalent. That means they have the same yes or no answer. Does P logically imply C? P implies a tautology, not P or C is a tautology, not C implies not P is a tautology, and P implies not C is a contradiction. I'm saying this again and again over several slides because it's important to understand that these statements are equivalent. However, proving one statement may be easier in some context than the other, and of course our goal should be to try to use a statement that is easiest for us to prove. The reason the questions that I had on the previous slide are equivalent is because of this like truth table. So what do we have to do when we want to prove P logically implies P? When P logically implies C, we need to see if is there any scenario where P is true and C is false. These are the scenarios we don't want, where P is true and C is false. Now, if you observe, this is exactly the thing ruled out by is P implies C tautology, is not P or C a tautology, not C implies not P a tautology, or P and C is a contradiction. And that's why all these statements are equivalent, and we should prove the one that makes most sense to us. So there are three different ways we can think of doing these proofs. One is a direct proof, where we start with P as our hypothesis and our goal is to reach the conclusion. The other is indirect proof, where I change this to not C implies not P, or I can do it as a proof by contradiction. That means I start with P and C and my goal is to show that it logically implies false. Now, there is some confusion that happens about these different types of proofs, and that's why I have put these couple slides to discuss what these differences are and are these methods really different. To show P implies C, let's look at what does it mean. That means we need a proof where the set of premises is P and the conclusion is C. So essentially, my proof method would look something like this. I will have some hypothesis H1, some more things H2, and in the end, I will go to show that my conclusion is true. So where do these hypotheses come from? This hypothesis now come from P because that is my hypothesis in the proof. If I wanted to show, on the other hand, not C implies not P, then we need a proof where the premise is not C and the conclusion is not P. In other words, I'm going to have a proof that is very similar, except that the hypothesis have to come from here and the conclusion that I want at the end is going to be this not P. In other words, if I'm going to do this indirect proof, my proof will end when I get to the when I get to the well-formed formula not P. Now the same thing will apply for contradiction. I will have a different set of premises and a different conclusion, but that's basically what I have to do. So you could think of these different proof methods like a recipe to write a proof. The only thing that is different, it's the same kind of recipe. The only thing that is different is every time you add different ingredients or add ingredients from a different box. If you're going to do direct proofs, then the thing that you add in the middle would come from P. If you're going to do an indirect proof, the thing that you add will come from not C. I'm going to put sort of one thing on this as very important for something that I want you to make sure you understand. And we'll do some of these proofs later. But after that, I want you to come back to this slide and see what the difference between the proof methods are. And if there are any questions, this is something you should discuss with me in class or in Piazza. Again, because there is often a confusion between these different types of proofs, I want to emphasize the proofs are essentially similar. Decide what approach you want to use, and the way you decide that, you are going to look at the formula P and C, and you are going to say, where can I start the proof with? If my formula P has a lot of interesting things that I can work with, I can start with that. If the not C has a lot of interesting things that I can work with, then I can start with that. So if it is P implies C, or is it not C implies P, or is it P and C implies F? Once you decide what you're going to follow, that is going to decide what your hypothesis is. So if you're going to follow a proof of this type, your hypothesis is going to be P. If you're going to follow this, your hypothesis is going to be not C. Here your hypothesis is going to be P and not C. Also, it's going to decide what your conclusion is, and your conclusion would be one of these depending on which proof method you decide to use. Now, the question you can always ask is, which method do I choose? And the answer to this is really there is no answer. There are no fixed rules for this. And a lot of this has to do with the fact that we can't have a generic automated proofs that will be able to write any proof that where the conclusion is true. This is something that, if you're interested, is called Gödel's incompleteness theorem. It comes up as undecidability results. So there is no automated way to do this for all possible scenarios. And so there's no sort of thing I can tell you that you should follow this rule if to decide whether you do direct or indirect or proof by contradiction. In many cases, you will be able to use any proof technique, but in some cases, and especially if I have a thing that I have to prove is of the form true implies something, then I would have to use proof by contradiction, something like that, because there is nothing that I can start with true that will help me start my proof. Once again, I will mark this slide as important. Again, something that we should discuss if there are any questions about it. Once again, we have reached the check before you go ahead slide. Now, what I want you to get from this part of the video was what are the different types of proof approaches, namely direct, proof by contrapositive, and proof by contradiction. And as I said earlier, the key differences in these are what is the hypothesis and what is the conclusion. So Here is a question. What are valid premises if I were to do a proof P and Q and R implies S? If I'm doing a direct proof, or if I'm doing a proof by contrapositive, or if I'm doing a proof by contradiction. Note that the answers are at the bottom of the slide, but I would like you to answer it yourself and verify that the answers match with what is expected. Note that with a couple of extra steps, proof by contradiction can be easily changed to proof by contradiction. Personally, I prefer proof by contradiction because they are more commonly used in practice. Proof by contrapositive is something that Rosen talks about, but it's not something that I have seen in all textbooks necessarily. But the difference between them is minor enough that if you have a proof by contrapositive, then essentially by adding a couple extra steps, you will get to proof by contradiction.